We need to expand in Taylor series this function about the point z equal to iota. It also we need to find the region of validity. So for that we have this function and we need to expand this function about z equal to iota, right? So let's make the partial fraction for this first. Just write here z minus 1, z minus 2, and when taking this denominator equal to 0, hide this z minus 1. We get z equal to 1. Put this value in this ratio. We get it's 1 divided by minus 1. So writing here negative 1. Similarly, when putting this denominator equal to 0, hide this z minus 2. And we have z equal to 2. Put this value over here. We get 1 divided by 1. 2 minus 1 is 1. So this is 1 divided by z minus 2. So this is how we make the partial fractions. And let me write this first. 1 divided by z minus 2 minus 1 divided by z minus 1. Now because we need to expand the function about z equal to iota, I need the terms in the powers of z minus iota, right? So let's add and subtract iota. So I'm writing here z minus iota, it also adding plus iota minus 2. Similarly in the second term also, I'm adding and subtracting iota. We need the powers in z minus iota, that is why I'm writing here z minus iota. Because we need the powers in z minus iota, let's take common iota minus 2 from here and iota minus 1 from here. So let's take iota minus 2 outside of this denominator, and we have z minus iota divided by iota minus 2 plus 1 minus, when taking iota minus 1 outside, we have z minus iota divided by iota minus 1 plus 1. So we have in the denominator something like 1 plus the term, so that when taking in the numerator we can expand this series, right? Let's take this denominator to the numerator, and because we know that the expansion 1 plus x to the power negative 1 equal to, it's 1 minus x, then plus x squared, then negative x cubed, so on to infinity. The alternate signs, right? So let's apply this formula over here. So this is equal to 1 divided by iota minus 2 and expanding 1 minus z minus iota divided by iota minus 2, then plus z minus iota divided by iota minus 2 whole square, then minus z minus iota divided by iota minus 2 whole cube, and so on. Similarly the second one, 1 divided by iota minus 1 into expanding this, so we have 1 minus this ratio and then plus the square of this ratio, and then minus the cube of this ratio, up to so on. Let's multiply this 1 divided by iota minus 2 inside and also this 1. So we have the first term to be 1 divided by iota minus 2 minus 1 divided by iota minus 1, right? Then plus the second term. Let me take z minus iota common from these two terms. So we have minus 1 divided by iota minus 2 whole square, and here plus 1 divided by iota minus 1 whole square, and we have taken z minus iota outside of this bracket. Similarly the next one, so that is 1 divided by iota minus 2 whole cube minus 1 divided by iota minus 1 whole cube, and z minus iota whole square will be taken outside the common, plus so on. So when solving the first term we get, this is iota minus 1, then minus iota plus 2 in the numerator. Cancelling these two we have 1 in the numerator. So 1 divided by product of these two, that is when taking the product we have It's iota square minus iota minus 2 iota plus 2. So this is negative 1. And we have minus 3 iota plus 1. And if I rationalize this, what I get? A square minus b square. That is 1 minus 9 iota square is negative 1. So this is plus. So this is 10 in the denominator. So the first term is evaluated as 1 plus 3 iota divided by 10. Evaluating the second term, this is negative of iota minus 1 whole square. So a square plus b square minus twice ab. Then we have plus iota minus 2 whole square. So this is a square plus b square minus twice ab divided by the product of iota minus 2 whole square and iota minus 1 whole square, their product. So in the numerator we have, this is minus iota square, this is plus iota square. Cancelling this is minus 1 then 4. So it is 3, then plus 2 iota and minus 4 iota. That is minus 2 iota. And in the denominator, okay, yes, also we have z minus iota multiplied with this. Okay, in the denominator we have iota square and 1 cancelled out, and here minus 1 plus 4, that is 3. This is 3 minus 4 iota, and here we have minus 2 iota. When multiplying we have minus 6 iota plus 8 iota square, that is minus 8. When we take negative outside we have 6 iota plus 8. So let's adjust this minus sign from the numerator. So this will be 2 iota minus 3, right? And in the denominator 8 plus 6 iota. If I rationalize this, 8 minus 6 iota divided by 8 minus 6 iota. When solving the numerator we have 17 iota minus 6, and when solving the denominator we have here 50. So this will be, if I take negative outside, this will be 6 minus 17 iota divided by 50. So the second term is with negative sign, this is 6 minus 17 iota divided by 50, and also z minus iota multiplied with this. Similarly, the third term will be minus 133 minus 81 iota divided by 500 and multiplied by z minus iota whole square. This is in the numerator, right? So on, up to infinity. It is enough to solve the first three terms because we need to show the powers in z minus iota in the numerator, right? Now we can expand 1 plus x to the power negative 1 as 1 minus x plus x square up to so on up to infinity only if mod x is less than 1. This is the condition for this expansion. So in our case, this is our x in the first term and this is our x for the second term. So for the expansion of this, what is the condition? That mod of z minus iota divided by iota minus 2 should be less than 1. For this expansion, we have the condition that mod of z minus iota divided by iota minus 1 should be strictly less than 1. Numerator is okay, fine. Let's check the denominator. What is the mod of iota minus 2? It is equal to square root 5. And the mod of iota minus 1, this one, this is equal to square root 2. That is, we are getting for this that mod of z minus iota is less than, strictly less than root 5. And for this, what we are getting? Same, the mod of z minus iota is strictly less than root 2. Right? So let's consider, let's write this, because square root 5 is already greater than square root 2. So I am considering this. So we have expanded the series for mod z minus iota divided by iota minus 1 strictly less than 1, that is mod z minus iota less than square root 2. What is mod of iota minus 1? How to be calculated this? Square of the real part plus square of the imaginary part under the root. So that is equal to square root of 1 plus 1, which is square root of 2. Right? So for this condition, the series is expanded about z equal to iota. And now we need to find the region of validity. Because our function is what? Fz is equal to 1 divided by z minus 1 into z minus 2. Now this function is not analytic at the points where this denominator is 0. So it is not analytic at z equal to 1 and z equal to 2. Right? Because at these points the function is not defined. The denominator will be 0, the function is not defined. So function is not analytic at these 2 points. So therefore, what is the radius of convergence for this? What is radius of convergence? It is a difference between, because we have 2 points where the function is not analytic. So it is a difference between, we need to take the minimum of these 2 distances. It is a distance between the point where the function is not analytic minus the point about which the function is expanded. Right? Similarly for this, the point where the function is not analytic minus the point where the function is about to expand, that is iota. So this is equal to the minimum of, we need to take the minimum value. What is the mod of 1 minus iota? It is square of the real part plus square of the imaginary part under the root. Then this is square of the real part plus square of the imaginary part under the root. So it is a minimum of, okay, this is 1 plus 1, that is square root 2. This is 4 plus 1, that is square root 5. Which is minimum? Square root 2. So the answer, the radius of convergence is square root 2. Right? So this is the region for the validity. So this is the region of validity. Hence the expansion is valid for, let me write, hence the expansion is valid for mod z minus iota less than square root 2. This is what we have mentioned over here also. Right? Okay, thank you. Stay blessed.